All right, thanks for coming everyone. I'm Nils Adermann. I've worked on Composer for a bit over 6 years now. It's its 6th anniversary in April this year. I think I gave a talk here before 5 years ago in 2012, kind of introducing the ideas behind Composer, or like what we were doing there at the time. And I think at the time there were a lot of people very unconvinced, and it's kind of difficult to explain to them why we really wanted to do all of this. And it's been amazing to see this huge PHP community kind of take on this project. Hundreds of people contributing to it, helping build it into the tool that we were hoping it could become one day. And I think it's been quite the success story. So I assume at this point that all of you actually have worked with Composer, because this is not another introduction to Composer talk, right? It's been a few years. Instead, I want to talk to you about the idea behind managing dependencies, because that's always what we say what Composer is. It's a dependency management tool. But what does that actually mean, and kind of what do you have to think about while doing this and while going through this process? I do have this thing called private packages on all my slides here, because while we've been doing this for 6 years, it's kind of difficult to have a big open source project like that and actually sustain its development for that long a course, because there's lots of people involved in doing this, and there's some, in particular, there's Jordi, who's doing most of the maintenance these days, which is taking up a large part of his time. So we started this new business called private packages that makes using Composer easier in businesses. It's basically a private Composer repository, much like what Packages is for open source, that companies can use both as software as a service or something to be used internally. So if you're working with Composer in a business, do take a look at this. And we're hoping to use this as a way to make Composer a long-term sustainable project that the entire PHP community can continue to rely on. Anyway, that's not what the talk is about. I just want to mention this so that the ones of you who are interested in this can take a look. Let's take a step back and just make clear what we're talking about today. So what are dependencies to begin with? And I'm not just talking about software libraries here, but I mean the dependencies of a project are varied, and there's lots of different things. We're not going to talk about, there's people working on your project. There are obviously dependencies in a sense too, where, this is not an HR talk or something like that. So we'll stick to the software bits. But I think there's two main things to think about, which are services and what I'll call software, which is the actual libraries or program tools you'll install. And services are either kind of external APIs you're consuming, or maybe some kind of client-side integration for third-party authentication, all these different pieces that kind of make up your application. And sure, you can also include something like external assets, that font that you're loading as part of your web experience. All of these are dependencies of the application of the project that you're working on. So if those are what is dependency management? And I like to kind of place this into these three areas. The first one I call assembly, which is simply the process of putting all of this together, right? You have all these different pieces, and in order to get your entire project application to run, you assemble all these pieces, you put them together into one whole application that will actually do what it's designed to do. The next part is dependency change management, which is making choices as to how to change dependencies, adding dependencies, removing them, updating them, and figuring out how this modifies the application, how this impacts what you're working on. And as part of what you're doing there, the key thing is that you're analyzing the risks involved in any of these processes, and you're trying to reduce them. Right? This is what you do as you're working on these different parts. And all of this does happen either at build time or at runtime. Right? Some of these services are pulled in while you're building your application, but some of them are used during runtime of your application. And all three of these steps kind of happen at both parts of your application. So I want to go through each one of these with you a bit, and then we'll look at different scenarios and kind of look at how can we analyze what type of risks are there and how do we minimize these. So I kind of explain what assembly is, but so what that consists, I mean, so you can think of this as the part, where you run composer install, that's assembling the different PHP libraries that you're using, but it's also the part where, your application runs in some kind of operating system, it has an environment that it requires to run in. So using your OS package management tool to install some software that's required, installing something like PHP itself in a particular version, that too is a dependency of your project. And hopefully using some kind of hopefully using some kind of configuration management tool to manage all of this. And the same thing too happens with services, right? So that kind of authentication that you have to set up to connect to an external service. Maybe the glue code between your application and an external API that you've written. All of those things kind of have to come together. And the main difference that you can see in how this process has changed over the last years, especially with those configuration management systems, and Composer is a big part of that too, is that rather than having these step-by-step installation instructions of the past where you get some README and you're going through, all right, I've got to install PHP, I've got to install this Apache module over here, I've got to make sure that I'm not enabling this configuration option in Apache. You kind of go through all of this, and at the end, you kind of have a working application. Maybe you have to delete some package. Instead, we're transitioning to a point where we describe the state of the whole system that an application requires to run inside of. Right? So we're doing this in the sense of describing what dependencies do we have in, let's say, a salt file, and then we have this tool salt that installs the right Apache module, that installs, Nginx and FPM in the right versions. And in the same way, a composer JSON describes the state that your application requires in order to run. And Composer is simply a tool to move whatever system you have into the state, right? It installs the right tools. It might remove something to make sure that the state matches your expectations and your application can run successfully. So on top of that, the next part is dependency change management. So the change itself here, what I'm talking about, I'm not talking about change management in the sense when you Google this and you'll find a Wikipedia article on change management. It's like this complicated process, very formally defined. I mean this in more of a colloquial terms if we're managing some kind of change there in very day-to-day regular activities. So the changes are simple operations that you would do with all these packages or dependencies, which are adding them, removing a new one, updating them, replacing some library, replacing some API with a new one by a different vendor, running a composer update, right, that modifies your dependencies. And the management is all about figuring out, like, what are the risks between running this old, outdated version? What's the new one, right? How much time do we have to invest in order to upgrade? What's that going to cost us versus the risk of staying on the old version? Figuring out what are the consequences. Maybe it's got unlikely but very fatal consequences to stay on the old version. So we should probably be investing this money in upgrading. And it's kind of a constant analysis of figuring out what are the advantages, what does it cost us, what are we doing here, and why are we doing it. Dependency change management too means architectural decisions that enable change, right? If you have something that's really hard-coded against this one particular version of some library, it becomes very hard to upgrade. So part of the management of change actually is anticipating that you'll have to upgrade this one day and making architectural decisions that will allow you to upgrade this library, right? Making sure that you're using a public, well-defined API that the library provides rather than all this internal functionality that makes it difficult to upgrade. But at the same time, also making the analysis and decision to maybe use the internal API because the business value coming out of it is higher than the potential cost of upgrading anyway. Or in the API sense, kind of building abstraction layers around them so that you can easily switch from one vendor to another, making sure that you can replace something. So let's start with the whole, how do we analyze risks? And the first thing I want to look at is availability. It's something that mostly affects the first stage, right, the assembly part. So in the very easiest sense, piece of software that we have is available if I have a copy of it, right? It's really straightforward. But if I use one of these package management tools to install these libraries, there's a really famous example from last year in the JavaScript world where somebody deleted an open source library, And without really intending for this effect, a lot of people could no longer build their applications simply because they relied on some library that relied on some library that relied on this small underlying little library that was deleted for entirely different reasons that had nothing to do with people using it for this purpose. And that's an issue of availability. If you don't have a copy of the software, it can simply disappear and you can no longer install it. Right? So that's one problem. But the same thing can happen with services. Right? You know, if your payment service provider suddenly isn't available anymore, like their service is down, obviously I can't process any orders. I'm going to lose a lot of money. And I think my favorite example of this is this service that validates European Union VAT IDs. I don't know if any of you had ever worked with this. So if you're processing like business-to-business transactions often enough, or like you require a VAT ID for your customer, and there's this great web service that you can easily use to validate these, and it's down, I don't know, I would say probably 2 days out of the week. I might be exaggerating a little bit, but that's what it feels like to me. So, you know, how do you deal with that? But I mean, I'm talking about things that happen with your application, or like as you're building it, but services too, right, can be at build time. Like even your local Jenkins installation that nobody's really maintaining anymore, and that suddenly stops working, right? That's also an issue of availability, and you can no longer assemble your application because your build server doesn't work anymore. So what can you do about all of these different things? Like I said, software is available when you have a copy. So where are copies if you're working on a PHP application, right? And more specific to Composer, Composer is a cache. And maybe worst case, you can recover some library from this cache directory, right? Maybe some developer around the Composer update still has a copy of it. Not very reliable, but it's good to know that this exists worst case. I've seen quite a few companies decide to fork every single open source dependency they have to avoid this issue, which, while it certainly reduces this risk because you do have a copy of everything, it also has the downside of involving a lot of work to actually keep all of these forks updated. And yeah, sure, maybe you can automate this, but then you spend a lot of time building automation around this, and certainly one approach one can take. In the Composer PHP world, something you can do is use something like the private packages service I was mentioning earlier, or use Status, the open source tool, to build your own Composer repository that keeps a copy of all of these packages, right? Just so that you make sure that just because some external part goes down, it doesn't stop working. And I think something that I'd like to point out here is what people don't realize about packages, like packages.org. It does not actually host any of the code that you're using. Packages.org is a metadata repository. It serves JSON information about what versions, what names of dependencies, and what download URLs they have. But the majority of open source software hosted on GitHub is actually downloaded straight off of GitHub. So if GitHub is down for some reason, you're installing software from packages.org, you cannot download any of the software. But the thing is, it's not limited to GitHub. I think something like 97% of packages are on GitHub. But the other 3%, which is a significant number, are hosted elsewhere. And sure, that's often also a highly available service, like let's say Bitbucket or a GitLab server. But that too could be that self-hosted Subversion server in the basement of some open source developer where they're still running this. And you should take a look at that, right? And actually consider, do I want to rely on this thing being available, or would I maybe want to make sure that I have a backup copy in case this thing goes down for a week because they're on vacation and can't fix it right now. So it's worth taking a look at where that actually comes from. For services, the situation is a little different because it's a little more complicated, right? You can't just make a copy of the service and keep it for yourself. It doesn't really work that way. But questions you can ask yourself is, can I run something asynchronously, like out of process for the user, for example? So with the VAT check, maybe I don't have to do that while the customer is ordering. Maybe I can simply say to them, sure, your order was registered. It couldn't be finalized right now. We'll email you about it later, or like notify you about it. And then I can have some kind of background process that checks, hey, is this API available again? And eventually, once it is there, I can validate the VAT ID and process the rest of the order, let the customer know everything is fine. Or if it fails, let them know, hey, we actually checked this later on. It didn't work. Can you please update your VAT ID so we can finally process your order? Right? Much better user experience than just having the thing not work. Like something when we were building private packages, like another example of this is we rely heavily on integration with things like GitHub, GitLab, Bitbucket, like external services, right? And they do at some point, sometimes they're slow, they run into some timeouts, sometimes they're not available. So I don't want a user who goes to our site to suffer from this, right? I don't want them to click on some link, just nothing loads because GitHub is currently experiencing some issue. So instead, you write background processes that fetch this kind of information, and you try to build a front end that doesn't directly communicate with these external services, but uses some internal proxy. And the important thing there too is you want to be able to inform a user rather than having a page timeout, right? If there's some external service that doesn't load, which always loads except for this one time when a user actually accesses it, right? Because if you're testing it, of course it works. It just, it might happen later. People forget to think about this. You should, when you're using some HTTP client library, actually think about what timeout you're setting there. Like make a conscious choice to decide this is how long a user should at most be waiting for this. And after that, they should get actual information, not just an error message that says an error occurred. It's like the worst user experience ever. Right? It's not just about the case when things go right, but especially when things go wrong, even though that might be uncommon and unlikely. But make sure that they can understand, hey, this didn't work because we weren't able to connect to this thing right now. You can try again later, or we'll notify you, something along those lines. But make sure that they don't just stop visiting your site because you're kind of expecting the service to be up all the time. Another type of risk, compatibility. This is not assembly anymore, but more the change management part. And the most obvious case of this, which I'm sure we've all seen before, is some backward compatible break in a library update. It happens unintentionally. It happens because we upgrade too far. But we've all been there where just suddenly something doesn't work anymore. Often enough, this is caught in tests because the whole there's some function signature change and it doesn't even allow that call anymore. Sometimes these things happen because there's semantic changes that you don't even realize until things go really badly wrong in production. And that too can happen with APIs. Right? Like one example I've seen at some point is one of these payment APIs that used to have credit card tokens that you would pass around. Now these tokens were expanded in scope because they wanted to support services like Apple Pay. And suddenly the meaning of this token is no longer a credit card, but any type of payment. And then if you make assumptions about what to do with it after, that may or may not actually work because some of these operations aren't supported for any token. Right? So the semantics of an API might even change, even though it's not obvious that the syntax of some call changed or that the number of arguments changed. So it's important to keep track of this. How do you reduce risk when managing change? And I was saying, one part of managing change is just when you add a new dependency, remove a dependency. So there's some criteria that I kind of like to use, and there's certainly not a full list of all the things you could possibly look at, but some of the important ones. When I add a new dependency, or if I take over some project that has a lot of dependencies and I want to review, hey, do I want to maybe look at one of these in more detail? Do I maybe want to replace one of these? And these apply both to software and services, some of them more, some of them less. I mean, it depends a bit on the situation, but one of them is, what is the number of maintainers and developers there? Do I rely on one single person, which may be fine in some cases, or is it like a large group of people I can rely on to get support from? Is it very actively developed? Right? Usually like a good sign that there's a lot of activity, that my bugs will be fixed by somebody else and I don't have to deal with that myself. May not necessarily be required, right? Sometimes there's small libraries that are just really key functionality that you want to use, which just haven't changed in years because they work, they're fine. So again, none of these themselves are like a clear decision, but there's something to look at while you're making this decision. Looking at how many users does some tool or library have? Is there a large community available to ask for help with, to compare with? Something that in the composer role can help with us is packages that shows an installation count. Don't rely on the absolute numbers there, because obviously this is triggered by, let's say, some continuous integration script and some number may be way higher than another. But just looking there, and if the number is 0, you can kind of be pretty certain nobody's using it. right? So it's more not necessarily comparing the exact number to another, but just getting an idea of like, is this actually in widespread use or not? Also something like what I was mentioning earlier, where is this library actually being installed from? Do I want to use this thing that's most likely going to be unavailable tomorrow? You know, where does it come from? But then maybe I can take another measure against that. And also look at what alternatives are there. How easy would this be to replace if this wasn't maintained anymore? Or how complex is it? Would I be able to maintain it myself if the maintainers who are currently working on this were no longer there? Is this something that's so vast in complexity that I wouldn't be able to deal with that? Then do I know someone who would be able to do that? Kind of think about what are the approaches if something bad happened to it. Like who here actually goes through a list kind of like this when they add new dependencies? That's a fair number. That's pretty good. Like something I skipped on here is like there's something that people love to look at for open source libraries on GitHub is this whole like how many GitHub stars does it have? And that's actually something I like to not look at because I've seen quite often that something gets extremely popularly discussed on Twitter for about a week. There's 1,000 stars on the thing, and then nobody ever touches it again. It sure is kind of a sign of, this is of some interest, or like it means something, but it's not necessarily a criteria I would use to judge whether I want to be using something on the long term. Right, so once we have the dependency, this whole compatibility thing comes in. And one thing that people are using more and more around, or to fix or to address this issue, is semantic versioning, which I'm sure most of you have heard of at this point as well. The idea is pretty basic. You have 3 parts of a version number. There can be some suffixes. It's this thing of X, Y, and Z. But the main promise it makes is that there will only be any backward incompatible changes that will prevent you from upgrading to a new version of this library, or some API even, if we increment the X. Right? So as long as Y and Z change, everything is fine. Only when I change the X, something breaks. Now this is entirely worthless if the developer of this open source library, or even if you're using this internally within teams, decides that this small VC break over here, it really doesn't require that I increase number X because it's really so small, hardly anyone will ever run into that. And then there's this one user who relied on this promise, and their application is broken because you decided not to increment X. So the biggest issue I see with semantic versioning is people who have very emotional feelings about their version numbers and who are afraid to increment this X part of their version number because it's not that big a change. And that actually entirely defeats the purpose of semantic versioning because you can no longer trust this library to not break. Because the whole promise of semantic versioning is that it will increment X if that happens. And the other issue with this is what is backward compatibility? Right? Sure, there's like obvious cases that we can probably all agree on where if I delete some function that used to be part of the public API, then that's probably backward incompatible. But I was talking about those semantic changes, and sometimes that's okay, and sometimes, or like what is the public API even? Maybe sometimes I consider something internal to my library that external people are actually using. So the true value of this promise really only comes out if you formalize what BC means. There's a great example that a Symfony framework put together at this URL where they define very clearly what they promise not to change between like backward compatible versions. And also what they don't promise to not change, right? So what they are willing to break so that you know what to expect as you rely on these version numbers. So if you are maintaining an open source library, take a look at this, maybe adopt this, or write your own, but at least clearly communicate this to your users. And on the other hand, if you're using a library, look at this thing and make sure that the way you're using the library, depending on what kind of version constraints you're using in the composer.json, actually matches up with your expectations. Right? And then if, on the other hand, people don't do this, it goes wrong, you don't longer trust them, a solution can be to simply pick more specific version numbers. Right? We would always recommend you use the caret operator, which is the semantic versioning operator, that follows exactly this promise. But if you know that this library doesn't follow it, then maybe use the tilde operator to only increment the last digit, or maybe use a specific version number and kind of, if you don't trust them, just modify how much you want to really update immediately, and then make more conscious decisions to review something as you update. There's lots of other ways to reduce compatibility. I mean, all these things that we do for various reasons, right? Like automated tests and static analysis can figure out some of these changes, like this tool called Fan for PHP that helps with this, that can help you figure out that you're making a call to a function that no longer takes that type of argument, or these types of changes. And obviously your tests fail, probably something went wrong as you're updating. There's manual ports too, right? Not just these automated things, like actually reading changelogs. Who here reads the changelogs of all the libraries they're updating before they run a composer update? Right? Like, I would be impressed if this was more people. And sure, that's understandable, right? It's a lot of research, etc. But maybe do that a little more often. Take a look at what's going on there. And if you're working on a library, actually write them. Because the most annoying thing is you're trying to do this, and over 50% of these libraries don't even provide one. And then you can go look at like Git history and like try and figure out what they did, and it's just impossible. So do actually write changelogs for people to consume and kind of make informed decisions on updating dependencies. And the other manual thing is kind of what I said with the version constraints, right? Just you gain experience. You know which libraries break BC often or not. That is just something, draw conclusions from that. So how do you, you actually run the update, like a little more specific to Composer now. The most common way is to run a Composer update. Composer update just updates every single dependency that you have. And much like what we're familiar with, let's say from testing, you want to have some amount of isolation so that if something breaks, you have an idea of where that problem comes from. If you're updating all your dependencies at once in this project that none of your colleagues touched in a year, it's just, you have no idea why it doesn't work anymore. Even on a project that you're actively working on that just has a lot of dependencies, if you only do this once a month, it's going to be a lot of things in there. So a good approach is to simply update your dependencies individually, one at a time, run tests, figure out, did something break or not, and then at least if something breaks, hey, it was this particular thing that I updated that caused this issue, and I know where to go looking and what to change. Now, of course, how do I even know which ones to update? So there's this option for update that tells the -- dry run that will give you the same output as if you had run a Composer update, but it won't actually do it. So you can run a Composer update -- dry run without any of the arguments. It'll give you a full list of what it would be updating, and then you can kind of go through those things. It's also great just for preparing the update, for knowing which changelogs to read, just getting an idea of what would happen, and then actually applying it piece by piece later on. So I mentioned that you should be updating this one package, but I think something that's not very well understood in Composer is how do these partial updates actually work. I have this really ridiculous example here of a package called Zebra that depends on a horse, a giraffe that depends on a duck, a horse that depends on the giraffe, and the duck that doesn't have any dependencies. And my project requires a zebra and a giraffe. So in a graph, it looks like this. I think that makes a little more sense, because otherwise I don't think any of you could follow what I'm talking about. All right, so all of these things I'm using currently version 1.0. And every one of them is now releasing a version 1.1. And we're looking at our project. Let's say this happened over the course of 2 weeks, and we're trying to update now and see what happens. So if I do a partial update of Zebra to 1.1, it will do exactly that. It'll update this one dependency. Now, often, horse isn't something that I'm using myself. It's not part of the dependencies of my project. It's just something that this library also uses. So usually, I don't want to go through, every dependency of every dependency, because then at some point it becomes unmanageable as well. So the update command has this option called with dependencies, which will go from zebra to its dependency horse, update that as well, go to its dependencies, giraffe, and oh, it won't actually update that one. The reasoning for this is giraffe itself is a dependency of your project that you manually put into your Composer JSON. And the whole assumption of Composer is that your Composer JSON defines the dependencies of your own project that you want to be managing. right? So like transitive dependencies of your dependencies, those are things you can kind of automate away. But the things that you yourself put in the composer.json, you probably have a very good reason to have put them in there. Like that's why things like version aliases only work on the root level of your project, because you make a very conscious choice that in your specific case, some library is compatible with some version that it doesn't actually say it's compatible or something like that. So the with dependencies will stop at anything that is on the root level of your project. So in this case, you could update zebra and giraffe, or well, obviously with dependencies, and then in this case, you would actually get all of these things. But the trick there is that anything on the root level is something you have to manually work with. Gets me to the log file, right? We did this update, we end up with the modified log file. Just to recapitulate what the point of the log file is. The dependencies of it is a list of all of these dependencies, right? All 4 packages in the previous example. For each of them, it specifies an exact version number. It specifies the URLs this package can be downloaded from. Both the Git repository is linked to the zip download file it can get download, or even mirrors, so like something like private packages will do that specifies multiple URLs for fault tolerance. Like all of those are in the log file itself, and hashes of which revisions you want. This is enough to install all of your dependencies, which is the trick to why composer install is so much faster. It doesn't look at your composer.json file. It doesn't try and resolve any dependencies. It just looks at this file, goes through each one by one, and just installs all of them without even thinking about it. Right, it's a very straightforward process. But the purpose of the log file is not just this improved, easier installation process. It's reproducibility across teams they're working with, for users of an application that you ship to them, or across servers if you actually run Composer as part of your deployment process. It helps you even in libraries because it isolates the cause of bug reports. Right? If with other people, like as a library, the log file will not be used because it only applies to the main project. But with other people you're working together on a library, who are running a test suite against a particular set of dependencies, even though that may not be what users end up with, it's useful to know that you're all communicating about the same dependencies. You gain a lot of transparency about the update process, because there's this log file that changes anytime I run a composer update, which I then commit to some repository so that all my colleagues can actually see and know, oh, hey, somebody ran an update yesterday. Because otherwise, the version numbers, as long as they still match the ranges, could just change at any moment. And nobody would really know, oh, we upgraded that to the new bug fix release, because it's just not documented in any way. So it makes this a lot clearer amongst everyone. And that's why you have to commit the log file. Right? If you don't, Composer install, and I'm hoping to kind of change this in a future major release of Composer, will actually run a Composer update. So I'm hoping that at some point we might change this so that Composer install will simply error and not do anything if you don't have a log file. Because you can't install dependencies without the log file. You will always be updating them, resolving dependencies, and changing them if you run without a log file. This affects the assembly part, because if you're assembling without a log file, you're actually doing an update, meaning some conflict can occur because those versions don't actually match with each other. And the assembly will just fail and you won't even get your dependencies together. You may not end up getting the same code that somebody else got with the same composer.json because the new version was released because some tag isn't available anymore. You have no guarantees. You're not managing the change anymore at that point. It's like the change is just managing you. It's just doing whatever it wants if you're not committing the log file. Right? So that's the whole purpose of the log file, is for it to be committed into versioning. Now, once you've done that, I'm sure that all of you have run into merge conflicts with the log file, right? Which is what people are annoyed about. But this happens for very good reasons. Like you can't merge a log file without conflicts, and part of that is because it contains a hash over the content of the composer.json relevant to generating it. I'll explain kind of why that is in a minute, but just to first start with how do you fix this? The only correct solution to this is to check out the composer lock of the base branch that you're working against, which you can do with git checkout and on whatever, like let's say master is the branch I'm based off of, and somebody committed a change to composer lock on the master branch, -- composer lock. I'll get the version that's on the master branch currently, and then I run the composer update again. Right? That's the only way to resolve this, is by running a composer update again. Now, of course, if you actually updated specific dependencies, like I was telling you earlier, you have to remember which ones did I run this with, which makes it important that when you do run a composer update with particular parameters, ideally you make a commit just of the log file, JSON file changes that contains the exact instructions for how did I get here, right? Which composer update command did I run? What did I update, etc., so that later this is easily reproducible. Right? So if I do run into this merge conflict, I can just look in the history and go, ah, that's the composer update command I used. I'll just run that again, and it's fine. Now, why is it that this is necessary? Let's look back at the example, right? So I have zebra and giraffe here on both sides. This is my master branch on the left here. Somebody updates zebra to 1.1, and this introduces a dependency on duck. Duck 1.0 is the latest at the time. Now in my branch that's based off of the previous version, I'm working on this 2 weeks later, but I'm using like this old version as a base branch, so duck is in there, zebra is still in 1.0. And I'm upgrading giraffe to 1.2. And that actually introduces the dependency on duck 2.0, because in this 2-week window, they released a new version, duck 2.0. So now I have one branch that contains duck 2.0 as a dependency of giraffe, and one that has duck as a dependency of zebra. If I was going to just merge this, like text-based between the log files, I would end up with this situation. I would suddenly have both version duck 1.0 and duck 2.0 installed side by side, because there are just two entries in the log file. Right? If I'm just merging these text-based, I end up with something that doesn't work in the PHP world, because both of these use the same class names. Right? They're in conflict with each other. This doesn't actually work. So if I rerun the update, though, Composer will realize, hey, if you're doing, like zebra 1.1 is now part of the log file that I'm rerunning this on, and I'm upgrading to giraffe 1.2, it'll go, oh, that's actually fine for zebra 1.1. We'll just have 2.0 from now on. That's the only thing that needs to be in the log file. And then I merge this back into this branch and don't do that silly thing on the left side. But that's why it's so important that the log file conflicts, because you do have to regenerate it. All right, enough for the whole updating. Some other type of risk analysis. Something that we as developers often like to kind of avoid even thinking about, compliance and legal requirements. This too affects change management. I mean, something that maybe if you work with open source, most people are familiar with is these viral copyleft licenses that aren't compatible with you shipping some proprietary license to customers. But there can be other requirements that licenses have that you can't actually combine with the second license, or that you're not allowed to use within a particular project, depending on what's happening with the code in the end. And with services, I think this is a much wider range of things that can happen there. You usually have some kind of terms that they come under, right? Like, am I even allowed to use an API for the particular services that I'm intent? So one example here is that people ask us, why don't you use Cloudflare for packages.org? There's some technical reasons for this too, about the frequency of updates is that they don't make it easy to actually use a CDN in combination with something like this. But apart from that, something that Jordi pointed out to me is that Cloudflare's terms of service quite explicitly state that it may only be used to cache HTML content. Yeah, we're shipping JSON data there. So yeah, sure, maybe this may work, but they could shut this down any day without notice. So that's not really something that we're willing to do, because a lot of people actually rely on this today. Or if they do terminate my service, how much time do I have to move elsewhere to renegotiate with them? What kind of statements do they make in their contract that guarantee me certain rights? Do they offer an SLA that actually has sufficient support for my requirements? If my whole business depends on the service working, I want to make sure that I can reach someone if there's a problem with it. So the way to minimize this type of risk on the software side is usually by picking the right licenses, like making sure that the dependency use the right licenses, maybe getting in touch with the authors about whether you can license it in a different way, or using some alternative that license correctly. But there's a couple tools that can help you with this. Composer licenses is actually a command that's built into Composer that will list you all the licenses that all the dependencies you have are published under, so you can easily review, is this all compatible with what I'm doing here? Or if you do something like private packages, it has those license review page that does this across your entire organization on all your projects. So it's like a little more easy from a business side to kind of look over this and all the different software projects you have. And for services, for terms of service, like SLAs, make this a key part of criteria for selecting a service, right? As a developer, you don't just pick it by, hey, this thing has the nicest API. Actually think about what comes with it. You know, what kind of promises do they make? What service can we expect? And usually they're negotiable, right? The thing that people forget is like, yes, sure, we're in this great time where to confirm the terms of service as you're signing up for something, you just have to hit a little button. But the thing is, you can also email and ask for things to be changed. In most cases, people are very open to actually doing that, right? It's nice for them to have some preset thing, but it's not necessarily set in stone. So do consider that you can really just get in touch with whoever's offering the service and ask them if they can maybe, make a different guarantee about something. And also think about this financially, because if your business is so reliant on the service, maybe it is actually worth spending some money on the SLA. Right? Kind of see, what is the risk that I introduce with this, and then maybe that's where I do want to be spending some money rather than hoping that it'll continue to work. And sure, at the same time, you have no guarantees that this won't go away. So kind of keep in mind that, if this business, I don't know, let's say the provider of the service goes out of business. Like, what are the effects of this on my own business? So what I'm kind of saying is formulate a plan B, right? In all these different steps, like know what to do if any of these things fail. But what I'm not telling you to do is to go and try and avoid any of these risks. Right? Identify the problems that are actually probable and that will have great effects on my business. But dependencies themselves are fantastic. They're great. They can save you huge amounts of money and time. That's why we use Composer so much. But you should be spending some resources on the few areas that are actually very critical to your business, where maybe you don't have an alternative, where figure out where the risk is the highest and try and lower it to an amount that's acceptable. Because you're not going to be able to get rid of all of these risks. They exist. They're there. It's just important that you're aware of them and that you consciously decide how to deal with them. So in summary, use Composer update with dry run and explicit packages. Use git checkout branch -- composer.lock to get back the composer.lock from another branch and update again. Formalize BC promises that you make for users of your libraries so that they know what to expect. Don't be afraid of increasing the major version number if you're using semantic versioning. Document changes to dependencies so that users, etc., know what's going on. And then as a user of dependencies, have a plan B. And even if that is just, we'll deal with it when the day comes because we've consciously decided this is not worth investing time and money into right now, right? But do make that decision at least once. And don't end up wasting resources on potential problems which are unlikely to occur or have insignificant effects, right? If I have to wait for my build for an extra 10 minutes, maybe it's not worth spending that much time and resources on building a better, I don't know, abstraction around it, running it on my own infrastructure, because that too may have come with greater cost. Like, do make use of dependencies. They're great. Their benefit is usually much greater than their cost is. Like something that I like to point out with this whole, how do you make this decision is this, who here has migrated a project from MySQL to PostgreSQL? Okay, who of you was able to do this without changing any of the queries? Right, it's not possible. The point is, something like a database abstraction layer is fantastic because it gives you like an easy way in for a new developers being onboarded. They're familiar with how to interact with the database. But the purpose of this is not to prepare for some very unlikely event, which would probably then have other problems anyway, of changing from one database to another. Right? The advantage of an abstraction layer like that comes from the learning and the better understanding of how to interact with the database, not from preparing for this weird, unlikely event. So, if you're a developer and you're using this one library, you don't really quite trust it, do actually think about it from a business perspective. Is it actually worth me spending 2 weeks on building this abstraction layer around it for potentially at one point switching to another payment API while I'm working for this startup that, been running for like 1 month and that probably don't have enough money to, outlast my building abstraction layers every day? So I think something that developers must do there is really consider this more from a business perspective, right? Maybe it's not the perfectly nicest, library that you ever wanted to use, but is it actually worth me spending huge amounts of time to write this wrapper in between? Sometimes it is, because it helps. Like, if you do make this business decision that, we need to protect ourselves against the service going away, we need to be prepared for switching to another one, sure. But, kind of communicate this across your business. This is something that you need to communicate a lot more with people who are making these types of decisions in their business. If you're more on the management side, right, actually take this seriously, because your developers make these types of decisions every day. They decide they're going to use this new little library over here. But this is something that can severely impact your business. So from that side too, you kind of have to, talk to them, communicate about this. What are they doing there? Why are they doing it? What are the risks involved in it? So I think it's overall, this is what I'm trying to do with like the last lines here. It's really just something that needs to be communicated a lot more and not just kind of happen on the side. And with that, thank you very much, everyone.